Morning, everybody. Welcome to the Right to Know meeting here at the Capitol. This is for the second phase of the restroom renovation project. My name is Dan Callahan. I'm with DMS. I'm the Environmental Health, Safety, and ADA Coordinator. I want to introduce you next to the key players of this project. There's multiple phases. There's at least another 5 phases to come. So this is going to be an ongoing project. So without further ado, let me introduce the contractor, Mel Kaysen. Mel, if you would.
Hi, I'm Mel Kaysen. I work with Kaysen Environmental and Demolition Services, and we're performing the demolition and also the asbestos abatement.
Okay. Next, we have Mr. Andrew Wellman.
Good morning, I'm Andrew Wellman with Childers Construction. We are the construction manager working on behalf of DMS to provide this renovation project here at the Capitol.
And finally, Mr. John DeLoach.
I'm John DeLoach. I'll be monitoring the project, taking air samples inside and outside to verify the integrity of the containment and overseeing the completion of the asbestos removal.
And John is with me here in Environics, by the way. Once again, this is an asbestos right to know meeting. We're going to be focusing on floors 10 through 12, and we're going to be focusing on the restrooms, men and women's, and also the adjacent janitor closets. We're going to be dealing with asbestos flooring, vinyl asbestos tile of very small quantities, asbestos mastic adhesive, and also any other mastic we may find during the demolition process behind walls and such. We're going to kind of discuss basically 3 key things. What is asbestos? How do we avoid any exposures to asbestos? And also finally, the actual abatement process. So anytime anyone should have any questions, feel free to ask. And also, for reference, we're filming this presentation, so if anybody should have questions down in the future or other phases of this project, it will be available for viewing, and also you can contact me directly with any questions or concerns. So basically, what is asbestos? Basically, it's a mineral fiber. It's been around, a long time, used in construction products. But the problem with it is that it breaks down into very tiny fibers, and it'll continue to break down to where it's more or less acts like a gas. It's microscopic, and it's 700 times smaller than a human hair. Which the problem with that is it gets entrained into your respiratory system, and it doesn't come out, so it causes other health effects. A lot of times it's mixed with other products. It was commonly used in, for example, flooring products, and it varies by, quantity of the product, and like thermal applications tend to have a lot higher content of asbestos. Where is it found? Here's some examples. Spray on fireproofing, structural steel is very commonly used. Insulation on pipes and boilers. Ceiling texture, vermiculite. Libby, Montana was a Superfund site actually where vermiculite was mined and used extensively throughout in the construction industry. Ceiling tiles for fire protection. Floor tiles, which normally have very low content and used basically for to help prevent wear. Putties, caulk, cements, very commonly used. Roofing shingles, another one. Siding on old buildings, if you see the scalloped siding on old houses, generally very hard cementitious material is usually asbestos if it's an old building. Joint compound and sheetrock. Ceiling texture is very common. Brake linings, plaster walls. A lot of the scratch coats sometimes may have it, or the top coat. Vibration connectors on air control systems. So when is it dangerous? There's two main categories, friable and non-friable. Friable meaning you can take the material and crush it with hand pressure and it'll emit fibers to a powder, more or less. That's friable. Non-friable is a material that is the opposite of that. Like floor tile and mastics, you cannot do that. You cannot make them emit fibers with hand pressure. Usually takes a destructive action. So how do you avoid exposure? Basically, the simple thing is, if you're not sure what it is, don't disturb it, for one. But we'll get into this a little more. You know, if all of the buildings by DMS have been surveyed to locate where the asbestos products are, and we verify that during any project as well. But you never want to drill, hammer, cut, saw, or sand or disturb asbestos-containing products, because you're going to emit fibers. So how do we deal with this? I mean, it's been around a long time, and back in the 80s, under AHERA is when it really became a big process in schools, K through 12, to deal with the asbestos issue, and that was expanded upon by AHERA regulations, which cover commercial and public buildings like these. So basically, you have to have some components to this. You have to have an abatement plan, which is performed by a licensed, Florida licensed consultant only. You have to have a licensed contractor. In this case, you met Mel Kaysen, and the abatement plan was developed by me here, the consultant. They perform all the air monitoring. It's third party. So, you know, we don't have an interest. The contractor doesn't have an interest. It's a third party doing all the air testing. And clearance testing to verify all the abatement plan procedures were followed, all the engineering controls were followed, and that the area is clean and safe to reoccupy. Containments. So the first thing they do as a contractor is they're going to seal off the work area with poly sheeting and tape. They're going to establish a negative pressure environment through special equipment that's a HEPA filter, which is high efficiency particulate air, which can filter down to 99.97% efficiency. It's lab grade air, basically. It's better quality air being discharged than what you're breathing right now. And they maintain a pressure differential of negative 0.02 inches of water column. So basically what they have, it's not really a vacuum, is you have a negative pressure being maintained inside a containment, you have fresh air coming in one way, air is being filtered and discharged on the opposite end. Here's a rudimentary drawing of it. Imagine a room. Here's the air filtration. You have banks of filters here, and then one large HEPA filter unit here. They usually have a primary and secondary filter system. A decontamination area would be over here somewhere. And the airflow is going to go this direction and then discharged out, and this is going to be lab grade air, which is discharged. And that's also monitored and tested by the consultant on a continuous basis. Here's a manometer, strip chart recorder. This is verifying that the negative pressure is being maintained. The contractor is required to do this. And the consultant will verify this, and it prints out pretty much hour to hour, day to day, what the negative pressure is. You need a minimum of 0.02 inches water column. And air monitoring is a key component to this. The consultant's responsible for it. They're going to maintain and monitor areas inside and outside the containment area for air sampling. The workers for exposures inside are going to be monitored as well. And here's some examples of some of the equipment they use. This is considered a low volume pump on the right here. That goes on the workers. It's battery powered, intrinsically safe. This is a high volume pump that's usually set on the outside, and these are the cassettes that you'll see. You'll hear these running, they'll make some noise. Not to be alarmed. That's just part of it. And what they do is they collect a measured volume of air through that cassette. And then they mount the cassette filter onto a slide, and they're able to analyze it on site. We'll get into that a little more. Here's an example of an outside sample in a hallway, kind of an ambient sample. Just making sure nothing's escaping or there's no problems with the containment. All this is done with always done by a licensed consultant. Here's some more of their equipment. This is called a PCM microscope. This is all the test mounting equipment. Maybe my pointer will work here. What they use is an acetone vaporizer. They'll take a pie-shaped piece of the cassette slide, or the cassette filter medium, mount it on the slide, and they'll collapse it with the acetone vapor. And then they'll use some triacetone and a cover slip, and they'll mount the slide together, let it dry, and then they'll run it through this microscope. There's a counting procedure that they've given the volume and concentration. They can calculate an actual concentration of fibers. For preparation, here again, the contractor will erect, poly barriers, critical seals. They'll seal all vents. Any HVAC systems will be sealed. Any penetrations through walls, ceilings will be sealed. So everything's sealed off. Here's some examples. I believe this was at the DEP building, if I'm not mistaken, where they did a floor-tile job here years ago. But what they do is, you can see they're erecting the poly containment. They're going to be dealing with the flooring product here. They'll seal up all these penetrations before they begin. Here they are. I guess this is after it's been cleared, where they did the removal. What they'll do is they'll put a lockdown encapsulant. After they do the removal, it's inspected by the consultant, and at that point they do the final air testing. And then once that is cleared, then it's open for reoccupancy. Here's some examples of some of the equipment. Here's a containment. It's prepped up all the way. I'm not sure where this is at, but this is, they're probably doing a ceiling material or something, because they've got poly all over the floors. Everything's sealed off. Here's a worker with his protective equipment, his respirator, protective suit, the old moon suit as people call it sometimes. Here's another project where everything is sealed off. Looks like they're probably doing something with the ceiling here. The walls, floors are all sealed. And there's negative air machines, I'm sure, in other rooms through here to draw air through here. Here's another worker using an airless sprayer, because it's important to keep the material wet. That's one of the engineering controls. He's got his full face on, HEPA filter, mask, and a suit, and he's keeping the material wet for removal. Looks like some kind of sealing product. And then post-testing, the consultant will perform the final air testing. Once everything's inspected, he's satisfied, they will apply a lockdown encapsulant to the area, and then at that point he'll let it dry and then run his final aggressive air samples. He'll blow it down, make sure he's getting anything that may be there residual. He can collect the air samples and read them. This is an actual PCM, they call it phase contrast microscopy slide, where this is what it looks like. ems.myflorida.com with my phone numbers. If you need to get a hold of me, or you have any concerns on this phase or any other future phases, please feel free to call me. And if that's it, anybody have any questions? Thank you very much.